My dear NEET aspirants and chemistry lovers, welcome to IIT JEE NEET classes. This is Ashok, chemistry faculty. Today I am explaining some more questions which are important to coming NEET 2026 exam. The question is given below are two statements. Statement 1, like nitrogen that can form ammonia, arsenic also can form arsine. Statement 2, antimony cannot form antimony pentoxide. In the light above statement, choose the most appropriate answer from the options given below. All 15th group elements, that is nitrogen, phosphorus, arsenic, antimony and bismuth, when react with hydrogen, form hydrates, that is NH3, PH3, ASH3, SBH3 and BiH3, that is ammonia, phosphine, arsine, stibine, bismuthine, like this. That is EH3 type hydrates. So statement 1 is correct. Statement 2, antimony cannot form antimony pentoxide. All 15th group elements when react with oxygen, form two types of oxides, that is E2O3 type oxides and E2O5 type oxides. So that is trioxides and pentoxides. That's why antimony also form pentoxide. So statement 2 is wrong. So the correct option is statement 1 is correct, statement 2 is incorrect. Option 3. The next question is, which among the following electronic configurations belong to main group elements? So what is the meaning of main group elements? Main group elements means the elements whose valence shell containing only S or P subshells. The elements which are containing only either S subshell or P subshell. That type of elements are called main group elements. These are group 1, group 2 and from group 13th to 18th. So these are containing S or P subshell electrons. So in the given options, neon 3s1, this is belongs to what? Sodium element. So sodium element is what? S block element. This is S block metal. So that this is main group element. Then come to the point of C, krypton 4d10 5s2 5p5. So the valency containing 17 electrons. It is a p block halogen element. This is halogen. So this is also main group element. Come to the point of B. So this is valence electrons containing in 3d orbital. So these are d block elements. So these are not main group element. Then E option, that containing 5f and 6d orbitals. So that this is near to F block element. So this is nothing but thorium. 6d and 5f involvement is there. So that this is also not a main group element. So that main group element is only A and C. So the option 2 is correct choice. So main group elements means the valence shell containing only S or P subshells. So option 2 is correct representation. The next question is the correct order of wavelength of light absorbed by the following complexes. This is from coordination compounds chapter. So here the crystal field splitting delta O, octahedral crystal field splitting, depends upon the field produced by ligand, that means ligand strength and charge on the metal ion. These two factors the crystal field splitting mainly depends. According to this ligands, the ligand strength is Cn minus is more strong ligand, then NH3 is more strong ligand, then H2O. This is ligand field strength. So ligand field strength increases, delta O also increases. Then charge. Higher the charge, high charge. So charge increases on the complex. Higher the charge on the metal ion leads to large splitting, and has higher delta O value. So in these molecules, CO plus 3 charge, then titanium plus 3, then Cu plus 2. So this is the order of delta O, octahedral splitting. So delta absorbed is inversely proportional to delta O, octahedral splitting strength. So more delta O, less wavelength absorbed, and less delta O, more wavelength absorbed. So that less delta O is copper. So C, option C is more wavelength will be absorbed. After that titanium, after that cobalt. So C, then D, then A, then B. So option 2 is the correct representation. In between these two molecules A and B, Cn is strong ligand, that's why large splitting, higher delta O, so that less wavelength will be absorbed. So that B option is least wavelength will be absorbed. So the sequence of wavelength is C is greater than B. So the sequence of wavelength is C greater than D greater than A greater than B. The next question is phosphoric acid ionizes in 3 steps with their ionization constant values Ka1, Ka2 and Ka3 respectively. While K is the overall ionization constant, which of the following statements are true? So phosphoric acid H3PO4. If you observe the structure of this molecule, this is H3PO4. So it can donate 3 protons. Basicity is 3. Basicity is 3. All the POH bonds, these hydrogens can most acidic can be donated. So in the first step, H3PO4 can be donate 1 H plus ion. It become H2PO4 minus. This is Ka1. In that second step, this H2PO4 minus can be donate one more H plus ion, become HPO4 2 minus. This is Ka2. Then again HPO4 2 minus can be donate one more H plus ion. Finally we can get PO4 minus 3, that is Ka3. So the overall H3PO4 can be donate total 3 H plus ions and PO4 minus 3, that value is K. So total the overall K value is the multiplication of Ka1 into Ka2 into Ka3. So the overall K is equal to Ka1 into Ka2 into Ka3. So if you take log in both sides, log K is equal to log Ka1 plus log Ka2 plus log Ka3. So here Ka1 value is greater than Ka2 is greater than Ka3. So that H3PO4 is stronger acid than both H2PO4 minus and HPO4 2 minus ions, because here after removing proton, so the negative charge increases on the ions. Because of that negative charge increases, to remove H plus ion from negatively charged species more difficult, so that H3PO4 is stronger acid than H2PO4 minus, then HPO4 2 minus, so that negative charge increases, to remove the proton is very difficult, so that acidity decreases. So this is strong acid. So remove proton from negatively charged ion is more difficult when compared to neutral molecule. So the correct options are A, B and C are correct options. So the correct option is fourth option. The next question is, Dalton atomic theory could not explain which of the following: law of conservation of mass, law of constant proportion, and law of multiple proportion, and law of gaseous volume. So we know very well, according to Dalton atomic theory could explain the law of chemical combinations. Law of chemical combinations. But it could not explain law of gaseous volumes. Law of gaseous volumes explained by Avogadro law and Gay-Lussac's law. Due to the law of chemical combinations, also called this law of chemical combination is also called law of conservation of mass, law of constant proportion, law of multiple proportion. All these three explained by law of chemical combinations. So Dalton atomic theory can explain all these three laws, but cannot be explained law of gaseous volumes. Law of gaseous volumes explained by Avogadro law or Gay-Lussac's law. The next question is, which one of the following compounds can exist as cis-trans isomerism? This is nothing but geometrical isomerism. We know very well, geometrical isomerism is a restricted rotation between carbon-carbon double bond. It requires restricted rotation. That means must and should be both carbon atoms containing two different substituents in both carbon atoms of the double bond. Two different substituents are present at each stereogenic center of the carbon-carbon double bond. Then only it can exhibit geometrical isomerism. If at least one carbon having same type of groups, that molecule does not exhibit geometrical isomerism. Must and should be both double bonds in that alkene carbons. Each carbon attached both groups are different groups. Then only the molecule exhibit geometrical isomerism. That is nothing but cis-trans isomerism. If at least any one carbon containing the both groups are same, that type of molecule does not exhibit geometrical isomerism. So come to the point of first molecule, 1-pentene. This is 1-pentene. So in that 1-pentene, the first carbon has both hydrogens same, so that this does not exhibit geometrical isomerism. Then 2-methylhextuene. So here 1, 2, 3, 4, 5, 6. 2-methylhextuene. Here also this carbon has both groups are same. That's why this is also not exhibit geometrical isomerism. So the next one is 1,1 dimethyl cyclopropane. In that dimethyl cyclopropane, one carbon can hold two methyl groups. So same. So this also cannot exhibit geometrical isomerism. So next one is 1,2 dimethyl cyclohexane. So this 1,2 dimethyl cyclohexane can exhibit cis-trans isomerism. Why? Because the both methyl groups present at the same faces are opposite faces. So both methyl groups present at above the plane. This is above the plane. So this is cis arrangement. Otherwise, both methyl groups present at opposite to each other. One is above the plane, another one is below the plane, that is trans arrangement. Trans arrangement. So that 1,2 dimethyl cyclohexane can exhibit cis trans isomerism because both methyl groups present at same faces are opposite faces. So the correct option is fourth option. The next question is match the list 1 and list 2. List 1 they given some compounds. In list 2 they given what are the hybridization exhibited by the compounds and their geometry or shapes of the molecules. Then we will discuss first XeO3. We know the simple method. Xenon belongs to 18th group element, that is valence electrons are 8 valence electrons. 8 valence electrons. We know very well oxygen can form 2 bonds with a central atom, so that it utilizes 2 electrons, 1 oxygen. So 1 oxygen utilizes 2 electrons, 1 oxygen utilizes 2 electrons. The remaining 2 electrons are there, that is 1 lone pair. So each orbit containing 2 electrons, that is s orbit, p orbit, p orbit and p orbit. So this is belongs to what? sp3 hybridization but containing 1 lone pair. Originally sp3 is tetrahedral with 1 lone pair, that is pyramidal. Pyramidal. So that XeO3 is containing sp3 hybridization and pyramidal shape. Pyramidal shape. So A is 2. Then come to the point of XeF2. Here also xenon is central atom. The valence electrons 8 valence electrons. So it is bonded with 2 fluorine atoms. Each fluorine also contribute 1 electron for bond formation. So this total containing 2 electrons. So 1 orbit. Then P. Then here 2 electrons, 1 orbit. 2 electrons, 1 orbit, because 1 orbit maximum occupied 2 electrons, that is sp3d. So that sp3d, how many lone pairs? 3 lone pairs. Generally sp3d shape is trigonal bipyramidal. Trigonal bipyramidal. So but here 3 lone pairs occupied 3 equatorial positions. The remaining is linear. So that xenon has linear shape. So here XeF2 is linear and sp3d hybridization containing 3 lone pairs. So that XeF2 is linear and sp3d. Next XeOF4. Here also xenon has the valence electrons is equal to group number, that is 8 electrons. Oxygen utilized 2 electrons but fluorine utilized 1 electron. 4 fluorines are there. Each fluorine utilizes 1 electron and fluorine also contribute 1 electron for bond formation. This total belongs to 1 orbit. This P, D, this 2 electrons belongs to 1 orbit. So total is what? sp3 d2 and 1 lone pair. Originally sp3 d2 is octahedral with 1 lone pair, that is belongs to square pyramidal. Square pyramidal. Square pyramidal, that is XeOF4. XeOF4 and 1 lone pair. 1 lone pair, that is square pyramidal. The next molecule is XeF6. So same like that, xenon valence electrons 8 valence electrons. It is bonded with 6 fluorine atoms. 6 fluorine atoms. Each fluorine contribute 1 electron for bond formation. So that total how many orbitals? S, P, D, D. These 2 lone pairs belongs to 1 orbital, that is D. So total is what? sp3 d3, 1 lone pair. Originally sp3 d3 is what? Pentagonal bipyramidal. Now because of 1 lone pair, it is having distorted octahedral. Distorted octahedral, that is XeF6. So this is XeF6. XeF6, then containing 1 lone pair. This is distorted octahedral. So this is also called pentagonal pyramidal. Pentagonal pyramidal. Pentagonal pyramidal. Originally sp3d3 means pentagonal bipyramidal. With one lone pair, that is called pentagonal pyramidal. This is also called distorted octahedral. So the correct representation is option 1. The next question is, out of the following complex compounds, which of the compound will have the minimum conductance is in solution? According to Werner theory of coordination complexes, CONH3 6 Cl3 can donate 3 Cl minus plus CONH3 6 plus 3. So total it furnishes 4 ions. 4 ions. Then CONH35 Cl Cl2, it gives 2 Cl minus and one complex compound CONH35 and Cl. So it gives total 3 ions. Then CONH3 4 Cl2 and Cl, it gives Cl minus and throughout this complex compound CONH3 4 Cl2. So it containing 2 ions. 2 ions. Come to the point of CONH3 thrice Cl3. CONH3 thrice Cl3. It does not give ions. No ions present because outside the complex there is no halide ions, so that it won't split into ions because the complex compound is very strong, so it cannot break into ions. Outside the complex, what are the ions? Halogen atoms are there, that only converted into ions. Inside the coordination complex, any ligands are there, it cannot be break into ions. So that which has the minimum conductance. So this is option 1 has minimum conductance because no ions exhibit in that solution. So this is maximum conductance. So option 3 is maximum conductance. Option 1 is minimum conductance because option 3 has produced 4 ions in the solution. More ions, more conductance. The number of ions increases, conductivity also increases. The number of ions decreases, conductivity decreases. So that option 1 has minimum conductance in solution. The next question is match the list 1 and list 2. List 1 example they given humidity, alloys, amalgams and smoke. The type of solutions in list 2 they given. So in that number 1 is humidity. Humidity. So humidity means the water vapor present in air. Water vapor in air. So it is a liquid in gas. Liquid in gas type of solution. So humidity is liquid in gas. Then alloys. Alloys are what? Homogeneous mixtures. Alloys are homogeneous mixtures of metals. So that solid in solid. For example, bronze, copper plus tin, both are metals. Then brass, copper and zinc. So these are alloys. So solids present in solid solution. So alloys are solid in solid. So we know very well amalgam. Amalgam means what? Mercury. Amalgam. So metals mixed with mercury. Mercury plus metals. That is zinc amalgam and sodium amalgam, like this type of examples. So liquid dissolved in solid metal. Mercury is liquid, it is dissolved in solid metal. It gives liquid in solid dispersion solution. Then smoke. Smoke means what? Solid particles suspended in air. That is solid in gas. Smoke. Solid particles present in air. Suspended in air. That's why solid in gas. So the correct option is A2, B1, C4, D3. That is option 2 is the correct representation. So this is the direct question from NCERT textbook. My dear students, I hope all of you understand that questions and all. So similar to these questions, all of you practice from NCERT textbook and other any materials and all. So I will explain most important some other questions in next video. So please subscribe my YouTube channel and click bell icon for daily JEE and NEET updates. Thank you one and all.